Hello student, welcome to the video lecture on digital image processing. As per RTU syllabus, I am covering the 5th unit, that is image segmentations. So now let us see what is image segmentations. The segmentations attempt to partition the pixels of an image into groups that strongly correlate with the object in an image. Or you can say segmentation subdivides an image into its constituent region or object. So the main purpose of subdividing an image into its constituent part or object present in the image is that we can further analyze each of these constituent or each of the object present in the image. Once they are identified or we have some divide them, so each of these constituent can be analyzed to extract some informations so that those information are useful for high level machine vision applications. So now image segmentation algorithm generally are based on two basic properties of intensity values like discontinuity and similarity. In the first category, discontinuity category, the basic approach is to partition an image based on abrupt change in intensity such as age in an image. The principal approach in the second category, which is similarity, are based on partitioning an image into regions that are similar according to the set of predefined criteria like thresholding, region growing, and region splitting and merging are the various examples of the second method in this category. Detection of discontinuities. There are three basic types of gray level discontinuities. One, isolated points or points, lines, edges. In discontinuity based approach, the partition or subdivision of an image is carried out based on some abrupt change in intensity levels in an image or abrupt change in gray level of an image. So under discontinuity based approach, we are mainly interested in identification of isolated point or identification of line presence in the image or identification of edge. The most common way to look for discontinuities is to run a mask through the image. A 3x3 mask is shown in the figure. This procedure involves computing the sum of product of the coefficient with the gray level contained in the region encompassed by the mask. That is with reference to R equal to W1 Z1 plus W2 Z2 plus dot 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 up to W9 Z9, where Zi is the gray level of the pixel associated with the mask coefficient Wi. The response of the mask is defined with respect to the center locations. So using the mask, we will try to detect the isolated point, or we will try to detect the lines present in the image, or we will try to detect the edge in the image. Now this use of mask we have already discussed earlier in connection with our discussion of image processing like image enhancement, image smoothing, image sharpening, and so on. The detection of isolated point in an image is straightforward in principle using the mask which is shown in this figure. The 3x3 mask have different value. The center pixels or center point coefficient is 8 and all other coefficient in the mask will have a value of -1. Now we say the point is detected at a location, say it is x, y in the image where the mask is centered. If the corresponding R value, we are computing the value of R. So we say that a point is located at a location x, y in the original image if the corresponding value of r, the absolute value of this, is greater than certain threshold, say t, where t is a non-negative threshold value. This is a non-negative threshold. So if the value of r computed at a location x comma y where this mask is centered, absolute value of r is greater than t, where t is non-negative threshold, then we say that a point, an isolated point, is detected at the corresponding location x comma y